Hi, today I'm going to teach you about this. This is a digital multimeter. The goal of this video is to teach you how to use it. This is a device for measuring currents and voltages in electric circuits. It can do a lot of other stuff as well, this particular model, but I'm going to focus on teaching you how to use this to measure voltages and currents in an example electric circuit. All right, so let me get a little closer here so you can see that this is a multifunction device. It's a multimeter. It can measure a bunch of different things. It can measure AC voltages, DC voltages, and it can measure currents in three ranges. This range is microamps, so millions of amps, milliamps, or amps, up to 10 amps. All right, so one thing to notice is in all multimeters will have this. I'm going to use this port if I want to measure large currents up to 10 amps, but I'll use this port over here if I want to measure smaller currents. And the reason there's two separate ports is the circuitry has to be different. You got to have different overage protection and circuit breakers, fuses inside of this device to protect larger currents compared to smaller currents. Okay, so again, my goal here is I'm going to show you an example circuit, and I'll show you how to use this device to measure voltage and current in that circuit. All right, here's my circuit. I have an Arduino Uno that is being powered by a 9-volt battery, and it doesn't matter what program is running on the Arduino right now. What I'm doing is I have a wire coming from the 5-volt output from the board to the power rail on my breadboard, and then current's going to flow through this 200 ohm resistor, through this column of the breadboard here, through this red LED, through that column of the breadboard, through this black wire to the other power rail, which is connected back to the ground pin on the Arduino Uno. So I have a circuit going from here through the resistor, through the LED, through these black wires back to the Arduino, and the LED lights up. Okay, so here's the question. I want to use the multimeter here to measure the voltage that's being used by the resistor. You want to make a prediction? The circuit is hooked up to a 5-volt output on the Arduino Uno. How much voltage is the resistor using? Go ahead, make a prediction. I'm going to measure it. I set the multimeter to the voltage DC setting because I have a direct current. It's not alternating. Now to measure the voltage that's being used by the LED, what I'll do is I'm going to put these leads, these contacts, across the LED, which means I'll put the red one, I'll touch the red lead to one of the pins on the LED, one of the wires, and the black one to the other. And we measure that the LED is utilizing 1.76 volts. 1.76 volts. Is that surprising to you? It's a 5-volt circuit. Why is the LED only using 1.7 volts? You have an answer? Well, let's see how much voltage the resistor uses. I'm going to measure the voltage across the resistor by putting one contact on one side and the other contact on the other. And wow, the resistor is utilizing 3 volts. So 3 volts plus 1.7 is approximately 5 volts. Let's see what what you see here is that there's 5 volts in this circuit. The resistor is using about 3 of those volts, and the LED is using about 2 of those volts. The total is 5 volts, and the reason they're sharing the voltage in this way is because they're hooked up in series. They're hooked up in series, so you got to share the 5 volts. All right, we're going to learn a lot about a circuit called a voltage divider circuit. This is a voltage divider. The total voltage is being divided between 2 things, the resistor and the LED. They're sharing the voltage. They're hooked up in series. Okay, I can show you that the total voltage is 5 volts. I just got to go, well, I'll go here across the power rails. Ooh. Ugh, it's hard to do. There it is. The total voltage is 5 volts for the entire circuit. So this 5 volts is being shared between the resistor and the LED. Next up, let's measure current. And I've done things very differently here. If I want to measure current in my circuit, I can't just, so I have leads plugged into the same 2 ports on the multimeter. The port over here, which the labeling, you see, this is the port you use when you want to measure voltage or milliamps or microamps and a bunch of other stuff. And then the other lead is in the middle port here, which you can't see it, but it's labeled COM for common. And it's called common because you use this port for all measurements. Well, that's one way to think about it. Okay, so how do you measure current? Well, when you measure voltage, the goal is to put the leads across the element that you want to measure the voltage of. So you can think of it as using the multimeter to measure voltage. You're using it to probe a circuit that exists on its own. You take the multimeter away and the circuit is still there intact. And so when you use the multimeter to measure current, you're using it as an ammeter. And the key difference here is that the ammeter is actually part of the circuit. It needs to be in line with everything else, hooked up in series with the circuit you want to measure the current of. In other words, in order to measure the current flowing in the circuit, the current has to flow through the multimeter in order to make this happen. So what I've done is I've used some other wires here. Current's going to flow out of the 5-volt port on the Arduino. It's not plugged in right now, but it will. I plug it in. It's going to flow through the red wire, which goes over to the multimeter. Current will flow through the multimeter, come out the black wire, which goes around here, and then that black wire connects to this wire, which goes to the power rail on my breadboard, and current then flows through the resistor, through the LED, and through these black wires back to the Arduino. So this is part of the circuit now. Current flows through it. If I take the multimeter away, the circuit won't work. So the ammeter, or this multimeter being used as an ammeter, is part of the circuit. So I'm going to turn this on. So you see right now, my multimeter is measuring 0 milliamps of current flowing through the circuit, and the LED is not on. If I supply some power, now the LED has come on, and you see now I'm measuring about 14 milliamps of current flowing through this circuit. So one thing to note here is that since there's only one branch in this circuit, it's just one closed loop. The same current, the 13.98 milliamps, flows through the ammeter. It flows through the resistor. It flows through the LED, and all of these wires back to the Arduino. Every component in this circuit is seeing 14 milliamps of current, or experiencing 14 milliamps of current. Okay, so that was a quick introduction to multimeters. We just focused on using them to measure voltages, where the multimeter is used as a probe, where you bring the leads in and touch 2 things in the circuit that you want to measure the voltage across. And then using it as an ammeter, it's actually part of the circuit. It's in line with the rest of the stuff in the circuit. All right. Thank you very much. Until next time.